All right, 1.2 notes. So in 2.1, we talked about our transformations. So we have a vertical translation. That's if we add outside of our parentheses. So if we add or subtract outside, we either move up or down. So adding or subtracting outside, that is up or down. If we add or subtract directly to the x inside, subtracting means that we go to the right, adding, we go to the left. If we multiply by a number that's greater than 1, that would be a vertical stretch. If we multiply the outside by a number that's less than 1, this says compression, but they also say shrink too. Compression or shrink. So this is multiplying the outside. We're not going to talk about horizontal stretches or shrinks. And then also, if we are multiplying by a negative on the outside, we have a reflection on the x-axis. So this is outside is the x-axis, inside is the y-axis. So we talked about all of these transformations in 2.1, but we're going to be applying them again here. So for horizontal translations, that is when we add or subtract inside the parentheses. So this is inside. So it's kind of a reiteration of what I just said. So we are subtracting from the input. We do that directly to the x. So if it says we have a horizontal translation, it probably wouldn't use the word horizontal translation. It would either tell you right or left, because that's horizontal. We apply that directly to the x. If we have a vertical translation, so up or down, that would be outside. So we add that. If we have parentheses, we add it or subtract it outside. So remember, adding is up, subtracting is down. And then for horizontal translations, adding is left, subtracting is right. So let's look at our first example. So it gives us a function, f of x is equal to 2x plus 1. We want to write a function g whose graph is a translation 3 units down of the graph of f. So we're going to take our graph of f and move it 3 units down. Well, down, we said we subtract. Does it happen on the inside or outside? Outside. So I take my function, 2x plus 1, and moving it 3 units down, I'm going to subtract 3 on the outside. So I just subtract 3. Do I have any like terms that I can combine here? 1 and negative 3. So this turns into 2x, what? Minus 2. So once you apply the transformation, simplify by combining your like terms. So this new function, they call it g of x, would be 2x minus 2. Any questions there? All right, let's look at b. B, we want to write a function h, so this one we're calling h of x, whose graph is a translation 2 units to the left of the graph of f. So 2 units to the left, left and right, is that inside or outside? Inside. So it happens directly to the x. And if I'm moving to the left, is that adding to or subtracting to? Adding moves to the left. So we would add 2 inside. So inside meaning that it's going to happen directly to the x. So my function here was 2. Now inside, I'm adding 2 to show that I'm moving it to the left, plus 1. So I just applied it directly to the x. Now how can I simplify this? I have to distribute the 2. So it'd be 2x plus what? 4 plus 1. Can I simplify any more? How? 4 and 1, so 2x plus 5. So our function would be h of x is equal to 2x plus 5. Inside applies directly to the x. So if it is left or right, that's inside, that's going to be applied directly to the x. So directly to the x. Up or down is just you add it or subtract it on the outside. Thank you. All right, let's practice some more. Let's go down to the bottom of the next page. So we have 1, 2, 3, and 4 at the bottom. We're going to do 1 and 2. So in 1, we have a translation 5 units up. So to move 5 units up, is that inside or outside? Outside. And am I adding or subtracting? We're adding 5 outside. So I would take my function, 3x, and just add 5 to the outside. So my answer here would be 3x plus 5. And it just tells me that I need to call it g. G is my new function.
If you're going to do it on the test, do you have to put gx?
The important part is this part.
Okay.
So just make sure you have that. I think on the homework, it'll probably give you like g of x equals, and then you have to put it in the box. I think that's how it writes it, or something like that. So for 2, we have a translation 4 units to the right. Does the right happen inside or outside? Inside. And 4 to the right, is that plus or minus? Minus 4. So we're subtracting 4 when we go 4 units to the right. Subtracting 4 on the inside. Here, we actually have absolute values that kind of act as our parentheses. So we're applying it directly to the x inside the absolute values. So this would be absolute value of x minus 4 and then minus 3 on the outside. We can't simplify this because we have absolute values. They're not like regular parentheses, so we just leave it. This would be as simplified as we can go.
You'd be able to simplify that if not?
If it didn't have the absolute values and it was just like normal parentheses, then yeah, you would want to simplify. So just like how we did in the last one where we had to like distribute and combine like terms, you'd want to. But if it's absolute values, think of absolute values as a brick wall. You can't add a number inside with a number outside of it. You just leave them there. All right, let's go back up. We're going to talk about reflections. So if we have a reflection on the x-axis, that happens outside. So when it's on the x-axis, we multiply the whole function by a negative. When it's a reflection on the y-axis, that happens inside. So just the x gets multiplied by a negative. So outside we multiply the whole thing. That's when it's on reflection on the x-axis. Inside just is the y-axis, just the x gets multiplied by a negative. So let's look at example 2. We want to write a function g whose graph is reflected in the x-axis of the graph of f. So x-axis, is that inside or outside? Outside. So outside means that the whole thing gets multiplied by a negative. So I'll write that down here. We have the absolute value of x plus 3 plus 1. So here, the whole thing gets multiplied by a negative, or -1. So when I distribute that, it's going to get distributed to the absolute value. It can't go inside of our brick walls in the absolute value, so it's just going to stay outside of the absolute value, but it also gets distributed to the plus 1. So it'd be negative absolute value of x plus 3 minus 1. You don't have to put the parentheses. Once you distribute it, they go away. All right, for B, we want to write a function h whose graph is a reflection in the y-axis. Is y inside or outside? Inside, and that happens directly to x. So inside of the absolute values, just the x gets a negative. So this would be the absolute value of negative x plus 3 plus 1. So just the inside, and it happens only to x. So this would be our answer here. Let's look at the 2 on the bottom. So for number 3, we have a reflection in the x-axis. So does that happen inside or outside? Outside. So what gets multiplied by a negative? Everything or just the x? Everything. So this would be negative times everything here. So negative absolute value of x plus 2 minus 1. Now when I distribute that negative, can I go inside the absolute value walls? No. The absolute values are brick walls. You can't distribute inside of them. So it gets distributed to the negative outside and to the minus 1. So here our function would be a negative times a negative would turn it positive. So positive absolute value of x plus 2 plus 1. All right, let's do 4. So we have a reflection in the y-axis. Is y inside or outside? Inside. What gets multiplied by the negative? Just x. So I'm multiplying a negative to this x. How would I write that? Awesome. Negative 1/2 x plus 1. So even though it's happening directly to the x, we wouldn't say 1/2 times a negative times x. No. Write it like you normally would. Negative 1/2 x plus 1. So just the x gets multiplied by the negative. All right, next we're going to talk about stretches and shrinks. So we're not going to do horizontal stretches or shrinks, so we can cross that one off. We're going to look at vertical stretches and shrinks. When you have a vertical stretch and shrink, that happens outside. And everything gets multiplied by that number. The difference between the stretch and shrink is that it's going to be a stretch when the number is greater than 1. So here it'll be a stretch if the number, it'll be greater than 1. Where does it say? Down here. Stretch is when a is greater than 1, and then shrink is when it's in between 0 and 1. But that happens on the outside, and we multiply it to everything. So let's look at example 3. We have a function h whose graph is a vertical stretch of the graph of f by a factor of 2. So vertical stretch means that we multiply by 2. What gets multiplied by 2? Everything. So just like how when we multiplied everything by a negative, we do the same thing here. We have 2 times the absolute value of x minus 3 minus 5. Can I distribute the 2 inside the absolute value walls? No. So it just multiplies to the outside and to the negative 5. So my function here, they call it h, so h of x would be what? How would I write this? Awesome. 2 times the absolute value of x minus 3 minus 10. All right, let's look at number 6 right below it. So here we have a vertical shrink by a factor of 1/3. So it doesn't matter if it's a stretch or a shrink. They both happen on the outside. And what does it get multiplied to? Everything. So stretch and shrink is almost the same exact thing happening. It's just going to be, when it's a shrink, the number will be a fraction. If it's a stretch, it'll be a number greater than 1. So we have 1/3 times the absolute value of x minus 3. Can I multiply the 1/3 inside the absolute value? No. It stays on the outside. What else does it get distributed to? The negative 3. So I have 1/3 times the absolute value of x. What is negative 3 times 1/3? Awesome, negative 1. If you need to, write it down. 1/3 times 3. You'd make 3 over 1, and then multiply your fraction straight across. So it'd be 3 over 3, which is 1. So that's how we get the 1. So this is g of x. All right, next we're going to be combining transformations. So we're going to be applying more than just one transformation to each question. When we do that, do it in the order that it tells you to apply the transformations. So in example 4, it says let the graph of g be a vertical shrink by a factor of 0.25. So let's apply that first. Vertical shrink by 0.25. We're applying that to our function x. So how do I apply a vertical shrink by factor of 0.25 to x? What do? What did I do in the last one? On the last page, when we had a shrink, what did I do? Multiply it to everything. But what is everything here? Just x. So 0.25 times x. Now, it is followed by a translation 3 units up. Plus 3 on the inside or outside? Outside. So this is outside. We're adding 3. So just add 3 outside. So this would be our function g. So 0.25x plus 3. Yes, David.
If it was inside, would it be 0.25 parentheses x plus 3 parentheses?
Yes. So if it was inside, you would either put it in parentheses or like you're applying it directly to the x when it's inside. I think there's an example at the end that we'll do that has an inside one. Any questions here? All right. For 5, we want to compare the graph of each function to the graph of its parent. We're not going to use a graphing calculator, but we're going to make sure that we're right. So here, our parent function, it could either be x squared, it could be the square root of x, the absolute value of x, just x. There's different types of parent functions. We're looking at like what gets added or multiplied or subtracted to the x. So if we're subtracting 4 on the outside, what does that do to our graph? Where does that move our graph?
Down.
Go down 4. For b, when we add 4 on the inside, what does that do? Left 4. For c, when we multiply by a negative on the outside, what does that do? A reflection on the x-axis. For d, when we add 1 on the outside, what does that do? Up 1. What about when we subtract 1 on the inside? Right 1. And then lastly, here, when there's no parentheses, it's implied that it's on the outside. So here we have a negative on the outside. What would that be? Reflection on the x-axis. So number 7 says let the graph of g be a translation 6 units down followed by a reflection in the x-axis of the graph f of x is equal to the absolute value of x. So this is our parent function. This is what we start with. We want to write a rule for g. So we want to apply the transformations in the order that it tells us. So if we have a translation 6 units down, how would we apply that? We subtract 6 inside or outside? Outside. So outside of our absolute value, we subtract 6. Then followed by a reflection in the x-axis. A reflection in the x-axis, we multiply by a negative to show a reflection, but a negative gets multiplied, is it inside or outside? Outside. So outside, does that mean just the x or everything? Everything. So everything gets multiplied by the negative. So when I distribute that negative, can it go inside the absolute value? No. So it stays outside. What else does it get distributed to? The negative 6. So it turns into what? Well, yeah, but what would the whole answer be? Awesome. The negative absolute value of x plus 6. And this, it tells us to name it as g. So g of x is equal to